So now we're looking at, again, two functions, u and v, that are dependent on x. And now we're going to see what happens when we multiply them together. So first thing, this should be familiar now, we need to compute what is the change in uv. So this is u of x plus delta x, v of x plus delta x, minus u of x, v of x. So at first blush, there's not, it doesn't seem like there's a lot we could do algebraically to work with this, but because I know where we're going, I'm going to introduce a real slick factor. So this is equal to u of x plus delta x, v of x plus delta x, and then I'm going to subtract u of x, v of x plus delta x, and immediately add it. So I haven't changed anything. And then we still have this term minus u of x, v of x. And at first blush, I may be wondering, why would I do that? Well, again, by subtracting and adding, I've just included a 0. But this expression has this common term here, v of x plus delta x, v of x plus delta x, that can be factored out. And the next group has the u of x and u of x that are common and can be factored out. And so I go ahead and factor those out. And this looks like u of x plus delta x minus u of x, the whole quantity, times v of x plus delta x. And then it's plus, and now I'm going to factor the u of x out, so plus u of x times v of x plus delta x minus v of x. And why this is such a nice feature is because this right here is just my delta u, right? That's delta u. And this right here is delta v. So recognizing that, I can rewrite this using that notation as the change in u times v of x plus delta x plus u of x times change in v. All right, so that's how I'm going to write du dv, and now I can compute the standard part. So the derivative of uv, their product with respect to x, is the standard part of the change in uv divided by delta x, or respect to delta x. Which, using this representation, is the standard part of change in u, v, x plus delta x, plus u of x, change in v, all over delta x. Breaking this up, this is the standard part of change in u over change in x, v of x plus delta x, times the standard part, plus the standard part of u delta v over delta x. Again, because we can distribute across multiplication, this is standard part of change in u over change in x times the standard part of v plus delta x plus the standard part of u times the standard part of delta v a little bit more room. So the standard part of u, standard part of x, this is the derivative of u with respect to x. When I standard part of v of x plus delta x, my standard part can distribute through, and that standard part of delta x is 0, so we're good there. And this right here is just u, because that's a real valued function. And finally, this is the derivative. So I get that this is equal to du dx times v plus u dv dx, or writing this in our form using differentials, duv is equal to du times v plus u times dv. So exactly what we wanted to prove in our statement.